All right, let's dive in. Today, we're going to peek behind the curtain and unpack the playbook that top tech companies use to make truly data-driven decisions. We've pulled together their best strategies into a single, powerful framework that you can start thinking about right away.
So how do the big players really do it? You hear all the buzzwords thrown around: A/B testing, data pipelines, causal inference. But here's the secret. It's not about one magic tool. It's about a chain of incredibly robust processes. And just like a real chain, it's only as strong as its weakest link. If one part fails, the whole strategy just falls apart.
So here's our game plan. First, we're going to lay out this core framework, the data-driven decision chain. Then, we'll break down each of its three critical links: how to build data pipelines you can actually rely on, how to measure the true impact of your work, and finally, how to run way smarter experiments.
Okay, let's get into the heart of it, the data-driven decision chain. It's a really simple but powerful way to think about how you get from raw, messy data all the way to a confident, defensible business decision.
Here are the three links. It's that simple. First, you build a rock-solid foundation with data you can actually trust. Second, you measure the real-world impact of the things you do. And third, you decide what to do next with real confidence. And here's the most important takeaway. A weakness in any one of these links, whether it's shoddy data, a flawed measurement, or a waffly decision process, it breaks the entire chain. Your whole effort to be data-driven just crumbles.
So let's dive into that first link, building. Look, you can't build a skyscraper on a shaky foundation, and you can't make good decisions with bad data. Your data engineering has to be absolutely solid. And for a lot of the best companies out there, that conversation starts with a tool like Apache Airflow.
Oh man, I think we've all felt this pain, or at least heard the horror stories. It's the middle of the night, your phone buzzes, and you know a critical report is broken. Again. This is the exact nightmare scenario that a robust data pipeline is meant to prevent. Reliability isn't some nice-to-have feature. It is the absolute foundation of your entire data strategy. This right here is one of the most common and most painful mistakes you can make in Airflow. See, the system is constantly scanning your files to check for updates. If you put a heavy database query in what's called the top-level code, like on the left, it runs every single time the file is scanned. It's like hitting refresh on a huge, slow website over and over again for no reason. It can grind your whole system to a halt. The right way, on the right, is to tuck that heavy lifting inside a task so it only ever runs when you explicitly tell it to.
This really gets at the core philosophy of building pipelines that don't break. These are Airflow's golden rules. Your tasks need to be atomic, meaning all or nothing. They have to be idempotent, which is a fancy way of saying you can hit the retry button as many times as you want without creating duplicate data or making a mess. And you've got to pass data the right way. Small stuff using Airflow's own system, and big data sets using something like S3. It's all about designing for failure, so when something inevitably goes wrong, recovery is clean and automatic.
Okay, so our data is flowing, it's reliable, awesome. Now we can move on to our second link, measurement. But here's a tough question. How do you measure the impact of something when you just can't run a perfect, clean A/B test? This is where Google's approach to causal inference is an absolute game changer. This is a situation that comes up all the time. You launch a big marketing campaign across the entire country. You can't just not show it to half the population to create a control group, right? So when your boss comes to you and says that sales spike is great, but was it really us? Was it the campaign? Or would that have happened anyway? How do you possibly answer that with any confidence?
Well, the answer lies in estimating something called the counterfactual. This is the key concept. We need to create a credible, data-driven picture of a parallel universe, a universe where the campaign never happened. If we can do that, we can compare that imaginary world to our real world. And the difference between the two, that's the true impact.
And this is how it's done. This chart from Google's research paper is so cool. Look at the top graph. That solid black line, Y, that's your actual sales. Before that vertical dotted line, that's when your campaign launched. The model just learns how your sales relate to other things that weren't affected, like X1 and X2. Then, after the campaign launches, it uses that relationship to predict what your sales would have been. That's the dotted blue line, your counterfactual. The shaded area in the charts below, that's the gap between reality and the prediction. That is your true causal impact. And that brings us to our final crucial link, deciding. Causal impact is fantastic when you can't run a controlled experiment. But what about when you can?
Well, even then, we can make the process way faster and more intuitive. Let's look at how Microsoft does this with their powerful take on Bayesian A/B testing.
Let's be honest, traditional A/B testing and its p-values are confusing. They're hard to explain and super easy to misinterpret. Plus, there's that big practical problem. You're not supposed to peek at the results before the test is over. The Bayesian approach, on the other hand, is so much more direct. It just tells you, hey, there's a 95% chance your new feature's actually better. See, it's the answer you actually wanted in the first place. And it mathematically lets you check in on the results whenever you want.
Now, you might be thinking, hang on, isn't Bayesian stats all about subjective prior beliefs? And that's where this gets really clever. Microsoft's method uses what they call a genuine prior. This isn't just someone's gut feeling. It's a belief that is objectively learned by analyzing the results of thousands and thousands of past A/B tests. You're basically using your company's entire experimental history to give your current test a head start.
The big takeaway here is that your testing program stops being a series of one-off questions and becomes a true learning system. Each new experiment isn't starting from zero. Instead, it's like you're adding another brick to this giant wall of knowledge, making every future decision more robust and every test more efficient. You actually start to learn what kinds of ideas tend to work in your product.
So let's bring it all back together. We've looked at 3 really powerful ideas from some of the leaders in data science. But they aren't just isolated tricks. The real power is seeing them for what they are, the interconnected links in a single, cohesive strategy.
And here it is, the whole chain assembled, the modern data-driven playbook. First, you build a rock-solid data foundation, using tools and principles like those from Apache Airflow. Next, you measure the effect of your actions, using causal impact when you can't run an experiment, or a smarter Bayesian approach when you can. And finally, with that foundation of reliable data and clear measurement, you can decide with real confidence.
So I want you to think of this chain: build, measure, decide as a diagnostic tool for your own team. And the question I want to leave you with is this: which link in your data chain is the weakest? Is it the build, the measure, or the decide? Because finding and strengthening that one link could literally transform your entire decision-making process. Thanks for tuning in.